It's been we've been running this course now for a few weeks, and we've really gone in depth on Git internals and the basics of how Git works. Now, there are quite a few topics that we didn't get to cover. Most importantly, we haven't had time to cover how to use tools like GitHub, GitLab, Bitbucket, etc. But what we have done is talk about distributed workflows in general, and the purpose of having your own private repositories that you can use as you see fit when it comes to finding a distributed workflow that fits the group. Now, most of you have probably used tools like GitHub and GitLab already. And since you have some experience, what I hope you'll do is you'll take away some knowledge about best practices and how you ought to, at least, how you should think about commits, what branches are, and that importantly that you should use branches. And you'll fit that into your workflow, because I know you are using GitHub for a lot of what you're doing, and maybe at some later point in time we'll come back to Git as a topic. We'll talk more in depth about how you use tools like GitHub and GitLab in a distributed setting. But for now, I will just ask you to go forth and explore after we're done with this course. Because what we've learned now are the basics, the things that you need to understand in order to understand the Git model. Once you've seen what commits really are, what branches are, how you merge, and again, some special topics like rebasing, which we will have a look at again today, as long as we have the time for it. You really know the basic elements of Git. You really know the the things you can do, and anything that comes afterwards is just a layer of abstraction on top of that. So, without further ado, I think we need to continue where we left off yesterday, because we were in the middle of writing a simple application together. And we were using Git and feature branching in order to create components of that application separately. And today we're going to create yet another feature branch. We're going to create yet another feature. And we're going to see how you can integrate separate features at different points in time, and how you can have different people work on different features and then integrate their work separately into a functioning application. Hopefully all of you have the work that we did yesterday. We created a repository yesterday. We initialized a Node.js application using Npm, and we created a few commits. We did some work and we committed it, and at this point all of you should have a repository that looks like this. Is that correct? Yesterday we created an index.js file which is pretty much empty. And then we created a feature branch where we implemented the print feature. A very, very simple feature. If we bring up the terminal, this is where we left off yesterday. The last commit was the one where we added the print function, or the print feature. And if we open up index.js, it should look something like this. we should have a simple print text function that we're invoking later on. And that will be the entirety of the print feature, the print functionality that we just implemented. Very simple for illustrative purposes. So is this where everyone is right now? Do all of you have a Git project, a Git repository with 3 commits? Have all of you implemented this print text feature, this print text function? And do all of you have a repository that looks like the graph we just had up on the screen, namely this? 3 commits, 2 branches, of which the master branch still points to the points to the simple version of index.js, the empty version, and all the work we just did happened on the feature/print branch. Is this where everyone is at? Yes or no? Just give me a thumbs up or a thumbs down. Just something that tells me that you're all ready to continue from here. Yeah, some of you have that. In fact, all of you should have that. I'm getting some more yeses. Okay, very good. Now, what we've done is to implement a feature in a feature branch. Now, remember that the master branch, that's really where our official code resides. That's where the code that is, if not fully ready to ship off, at least it's tested and feature complete. The features that are implemented on the master branch are fully implemented as far as the developer team knows. What happens when you're done with a feature branch is that it should get merged into the master branch. And we've looked at merging and what it does. So it is about time that we merge our feature branch now, isn't it? Well, yes, we're nominally done with this branch. But what we're going to do now is we're actually going to pretend as if we're not ready to merge that feature branch yet. Maybe we're on a different team and we're working on a different feature. Or maybe you just want to put that feature aside for the moment, implement another feature and come back to the print feature later. So what we're going to do now is we're going to pretend as if we're going to forget about the work on the print branch for the moment, and we're going to implement a completely different feature. Right? Now, what we're going to do is to do what any developer would do coming into the project, and that is they should check out the master branch. So at this point, in your terminal, run git checkout master and check out your master branch again. Now, all the work that is done on the feature branch still exists. It's still inside Git. But what we've done now is to check out the content of the commit that the master branch points to, i.e. the head of master. And if you look at your working directory, you have the index.js file there, but if we inspect it, it's very rudimentary. It's just that shebang statement and nothing else, which is what we checked in when we created that commit on the master branch. So, has everyone checked out the master branch? Or did you run into any problems? A very common problem you could run into. Let me show you that. I'm going to check out the feature branch again. Is that you have some work that you haven't committed in the working directory. Uncommitted work. this is not committed.txt. So there, we have a text file there that's not committed. I don't want you to do this, I just want you to follow what I'm doing. If you now check Git Status, it'll tell you that there is a file that's untracked and that hasn't been saved. Actually, that should be fine. If we do git checkout master, all the other files should change. This is not committed text file will follow along, and that's okay. However, if one of the files that Git knew about was changed, like index.js, let me check out the feature branch again. Sorry, we're yet again on the feature branch. If one of these files had changed, the files that are in the index and that Git knows about, have been committed. There, check Git Status. Now we have a modified file. Index.js has been modified. It's known by Git and it is changed since since what was committed. In this case, if you run git checkout master, it'll tell you that you have changes that haven't been committed, 2 files that Git knows about. And in this case, you either have to commit the changes by creating a new commit, you have to discard the changes completely, or what you can do is you can actually stash them, meaning that you put all the content of those files into a separate bucket of changes that you can later on ask Git to restore for you. If you're in the situation where some changes had happened to your files that you're not ready to commit, but that you don't want to fully discard, you can run git stash. And what will happen is basically that Git creates a commit out of everything in that working directory that wasn't staged and committed. It creates a commit out of that and puts it into a separate box of stash. Basically commits that you haven't put into the Git graph, so to speak. You can later on actually get that work back by running git stash pop, and that's like checking out that commit again. So we don't have much time to really go in depth on what happens with the stash, but if you're in the situation where you were not able to check out the master branch again because you had some changes, you had some modifications to your files that you didn't want to commit, just run git stash. Okay? At any rate, what I really want you to do is to check out the master branch. So, after all is said and done, I hope all of you now have checked out the master branch and you've verified that the content of your working directory is what you expect it to be. So, again, have you checked out the master branch now? And have you verified that the content is what we expect it to be? I'll remove that text file. We don't need that. Your content should look like this. Yes or no? Yes. Okay. Now what we're going to do is we're going to pretend as if we're working on a different team, or we're working on the same team. Maybe we're just one person working on this application, but we want to finish the implementation of another feature before we do anything else to that print feature which we worked on. So we're working on features separately. And you can always do that. If you use branching in Git, you can work on different parts of your application and juggle between them as you see fit. So again, we're going to check out a new branch that we'll call feet colorize, using the American spelling. We've now created a new branch which will hold the colorize feature, the feature that will enable us to colorize text, to make our text nice and colorful when we print it. And if we look at our diagram, at this point we've created another branch, but we've created it at this commit, the one that master pointed to, the head of master. Feed color. This is where the colorize branch is at. And if you bring up the terminal, and if we now do git log graph, right now all you can see is the history of the feet color branch, the feet colorize branch. That means all you can see is the part of the graph that contains the head of feet colorize, as well as all the nodes in the commit graph that are reachable going backwards through the graph from that commit. If you want to see everything, if you want to see all the commits in the commit graph, not just the history of the currently checked out branch, you can run git log graph -- all, and you'll get everything. Let me see here. Yes, and it even shows us the stash, which is cluttering up it's cluttering up the graph right now. Let me see if I can just remove that, because I don't want that in our graphs. Git stash pop. Oh, I regret showing you this now, because it's actually becoming a bit of a nuisance at this point. We didn't have to cover that. So just disregard what I'm doing now. What I'm doing now is just to get rid of the stash commit that we just created. What did we do? Git. And just disregard what I'm doing. I'm just trying to clean up the mess that I made in order... I'm going to clean up the mess that I made trying to show you a useful feature. Okay, hopefully now, if we get graph, log graph, it's not there anymore. Very good. Git colorizing. Okay, there. If you do git log graph all, it should look like you see up on the screen now. There's a colorize branch. Head is pointing to it, meaning that's the currently checked out branch. It's pointing to the same commit as the master branch, as it should. The feet print branch is still there, and the commit exists on the graph, but it's not checked out. So that's where everyone should be right now. Now what we're going to do is we're going to open the index.js file, which is now very clean. It doesn't contain any of the work done on the other feature branches. And that's good, because right now we're not concerned with that work. What we're going to do now is we're going to implement a function which will randomly colorize text. Okay, it's going to take a text string and it's going to return a colorful text string. And there's actually one thing we need to do before we can do anything to index.js, and that's to install a library which will make this possible, or make it easier for us. So the first thing we're going to do is to run npm install colors, which is a library that will enable us to color text. And you have to run -- save in order to save the entry to the package.json file. So the first thing we'll do on our new branch is to run npm install. Okay? And I want all of you to do that and tell me when you've done it. And I think all of you should have npm installed. We checked that yesterday. So you should have the necessary tools to do this. Run npm install colors, which is the library we're going to use, -- save. And remember, all of this should happen on the feat colorize branch. So make sure you're on the right branch. And once you've done that, you can run Git Status to see what has happened. And you'll see that the package.json file has been modified. And also we have some new files in the directory. And they show up as untracked files. And that's packagelock.json, which is a file that tells npm which versions of the libraries that we have installed that we need. And we have node modules, which contains the actual code for that library. So, all right. We're going to have to commit our work now, because we've made a change to the repository and we need to commit this. But what do we need to commit? We need to stage package.json at least. We want that as part of the commit. And packagelock.json as well is something that we want to bring along, because it says something about which versions of the libraries that exist in npm are needed, which versions are needed by us. However, when it comes to node modules, you generally don't want to check that in, because you can always recreate node modules by running npm install. The whole point of having the package.json file is that it tells us which libraries from npm that our project uses, and we don't want to actually include that code directly into our own project, because that part of the code is maintained by npm. So we don't want to check in node modules. We don't want to stage it, and we don't want it to be part of our commit. Now, there's always going to be a node modules directory in our working directory, because whenever we run npm install, it's going to show up. So what we want to do is to tell Git that you can ignore this directory. It's going to be there whenever we have the code checked out and whenever we've run npm install on it. But we never want Git to complain about it not being checked in. It's not supposed to be checked in. It's not supposed to be known by Git. It's supposed to be fully ignored by Git. And there's a way we can do that. There's a special file called the Git Ignore file, whose name is .gitignore. And inside that file, we can put the name of any file or directory we want Git to ignore, and it will henceforth be ignored by Git. So what I want you to do is to open .git ignore, or I want you to create a file called .git ignore. And inside that file, I want you to put node_modules / it's a directory, and save it. So what we just did was to create a file called .git ignore, and inside that file we put the name of a directory we didn't want Git to know about or be concerned about, namely node modules. So right now, after we created the git ignore file, if we run git status, you can see that it no longer tells us that node modules is untracked, and that's because it is ignored. On the other hand, we now have a new file called .git ignore. And that file we do have to commit. We do have to stage it and create a commit. So, you all following me so far? What we did was to install the colors library with npm, and we created a git ignore file. Those are the two things we just did. Are you happy about that? Do you need some more time to catch up? Or is this where everyone's at right now? So just to reiterate, we ran npm install colors save. That's what we ran in order to import the colors. Sorry, misspelled that. The library is called colors. In order to include the colors node library in our code. When we had finished running that command, we got the package.lock.json file. The package.json file was modified, and we got a node modules directory. After that was done, we created a .git ignore file. Now remember, on Linux, any file that starts with a dot is hidden by default. In order to show those files, you have to use the -a flag with ls, and it'll show you all the hidden files as well. So if we run ls-a, it'll show us that there is in fact a .git ignore file here as well that we created, and it just contains the name of the files and directories that we want Git to ignore. In this case, just the single directory node modules. So, is everyone happy? Or is anyone confused? Did I confuse you with all the stashing that I did that I maybe shouldn't have? Or are you happy with where we're at? At this point, we're on a new branch called feat colorize. We've installed a library using npm, and we've created a .git ignore file. Everyone happy? Or not? Feel good? Is everyone there? Is everyone fine? Or should we give it a couple more minutes for people to get to this point? What do you say? Look around you, check on your neighbors, the people who are in the room with you and see if everyone's caught up or if we need some more time. I'm not going to continue unless you tell me that everyone is ready and we can move together as a class. So how you doing, guys? You're good? And you're all good? All of you? Yes. Okay. I'm going to assume that everyone is now ready to move on, and if not, then just say so. Just say so in the chat. But we're going to move on. Unless someone says that we shouldn't. Okay, at this point, we have some work that we need to commit. So let's see, run Git Status, and you'll see that package JSON has been modified. So we need to stage package JSON. So we're going to run git add package JSON. We also have a .git ignore file, which we want to commit, and we have a package lock.json. Those three files should be staged. So we're going to run git add, and then the names of those files. Then we're going to check that everything has been staged, and it now says changes to be committed, those three files. We're going to commit them, add colorize, no, what's the name of the library? Add colors library. Okay. We committed the changes we just made, and we created a new commit on the feet colorize branch. Well, what does that do to the graph? Let's bring up the diagram. So the commit we had checked out was this one, the add index.js commit. Let me just make this a bit bigger for you. And what we did was to create a new commit from that one. Called add colors. And since we committed this on the feet color branch, this label moves along. And this is now what the graph looks like. We have this commit down here, which was the basis, it was used as the base for two other commits. The add print feature and the add colors feature. So there's a fork here where we used this commit as a base and we added to it, and we went in two different directions. In one direction we we've started the add color feature, at least. We haven't fully implemented it, but we added the library. Some work has happened. And then we have this add print feature, which is on a different branch, which implemented a different feature. And we're going to integrate this work. There's a fork here. We're going to bring everything together, but we need to finish our colorize feature. So let's do that. You need to open index.js. And now that we have our colors library, we should be able to use it by using node's require subsystem. So var colors is equal require colors. Hopefully this is something you've seen before in Node.js. At least the old version of Node.js, the way you import libraries is through the require function. Require and the name of the library you're importing, and you're getting an object back which contains the methods of that library. Well, methods and data types, etc. Everything inside that object. Okay, and now what we're going to do is to create a function that we'll call colorize. And it'll accept text, a string of text as its input. And what this function is going to do is to choose a random coloring and apply it to the text. Because it turns out that the colors library comes with a variety of functions with different names that we can use to colorize the text. So let's create an array which will contain some of these functions, some of these styles. And if you don't know them, you can check out the colors library on NPM's website, and it'll bring up the documentation and it'll tell you which colors are available. But you don't have to do that now because I've picked some colors for you. So let's use colors.rainbow, colors.trap, forget what that is, colors.inverse, I think that's white on a black text on white background, colors.random, I think that's a random solid color, colors.zebra, forget what that is, some black and white text, I guess. Okay, we put all of those styles into an array. We created an array of different functions, and we're now going to pick a random one of those functions inside that array. So one of the easiest ways of doing that is probably just to pick a random number between, well, a random index in the array. So since we have 1, 2, 3, 4, 5 functions inside that array, it should be a random number between 0 and 4, right? So let's see here. Math.random returns a random number between 0 and 1, and not including 1. Then we'll, by multiplying that by styles.length, we should get a random number between 0 and the length of the array. But of course we need this to be an integer, so we're going to pack that in math.floor, which rounds down to the nearest integer. So this should be a random number between 0 and the maximum index of the styles array. As in, it's a random index in this array. And then we're going to pick a random style from the array. Random style equals style random. Okay. And the last thing we'll do is to apply that random style to the text and return it. Return random style text. Okay, so this should be the entirety of the colorize feature, and I'm sure it'll take you a little while to type this up, but I hope the code makes sense to you. All it does is to accept a piece of text, a string, as its input. Then it picks a random style from the colors library and it applies that random style to the text and returns the transformed text. So I'm going to give you a few minutes to actually type this up. Just tell me whenever you're done and ready to move on. So I think the rule of thumb in the radio business is you should never have more than 6 seconds of dead air. I'm blatantly breaking that rule. I'll try not to interrupt you too much while you type this up and while you implement this feature. At the same time, I'll make sure that you can hear that something's going on here and the feed isn't dead. Now I think most of you, if not all of you, are familiar with JavaScript as a language, and hopefully the code makes sense to you. If not, you can take this as a crash course on JavaScript programming. So where are we at, guys? Now, in order to quickly test that this works as expected, just add the line console log colorize. This is a test, and invoke that at the end of the file. I'm going to save, run index.js. Oh, I forgot. I need to make index.js executable. And it gave me a colorized result. Let me try and run it again. Still the same one. That should be a fluke, I hope. And that is probably the rainbow color. And that looks like a zebra. Ah. Ooh, not even sure which one that is. This is a test. Is that what it says? So there we go. It seems to work. Every time you run it, you get a new random coloring of your text. Okay, let me open the index.js file again and remove the test, because we don't want to check that in. I just wanted to verify that the code works. And so should you. Just make sure to test the code, verify that it works, and save it. So how are we doing? You're doing good. Very good. Now I can see that it's already 10 to 11, so I realize it's already getting pretty late. On the other hand, I'd really like to finish up everything we need to do here. If you have somewhere else you need to be, then I fully understand it. I won't be mad if you have to leave now. For the rest of you, I hope it's okay with you that I'm going to run this class for a little bit longer today, just to finish up everything and tie everything together. You're free to stay. I'd love it if you could stay for the next, let's try and do it in 10 or 15 minutes. Otherwise, I understand it that you're busy people and so on, you have places to be. But I'm going to continue until we're done today, since this is our last class. And I hope that's okay with you. So, is everyone ready? Has everyone typed this up? Yeah? No? What's the situation like? All right, is everyone ready? Or is it just a few of you? Lots of you are ready. Those of you who are ready, can you please check on your fellow recruits to see where they are at and assist each other so that all of you can get to this point. Lots of you seem to be ready. If everyone could just say everyone's ready whenever everyone's ready, then I know that everyone is in fact ready. Because I don't have a list of who's in attendance today. We're all ready. Amazing. Awesome. Okay. Very good. Then we're done with this feature. Save it. Run Git Status. And the only file that's been modified is index.js. Very good. That's what we expected. Add index.js to the staging area, to the index, and commit the changes. Git commit. Add colorize function. And once you've done that, the next question is, of course, what did that do to the diagram, to the Git graph? And we had, so this commit was the one that was checked out, the add colors commit. So that becomes the parent of the next commit that we just created. Add colorize function. And the branch moves along. So this is now what our repository looks like. And if we bring up the terminal and we run git log graph, and we want to see all the commits, let's see if this doesn't make sense. You can scroll up and down with your up and down arrows, of course. So let's see, here at the very bottom we have the initial commit. Then we added index.js. And then here's the fork where print feature is on its own it's on its own branch. It's split off in a different direction in the graph. And if we follow the other path, we get to add the colors library and add colorize function, both of which are on the feat/colorize branch. And that is exactly what we had in the diagram of our repository. This is our graph. And now what we have to do, now that we basically have all the features needed for this entire program, we need to start integrating the work. So now I'm going to ask you a question. And it's going to be about merging. And it's going to be about fast forwardable merging. Okay? Is the feature print branch? No, let me put that differently. The wording is important here. If we want to merge feat print into master, is that merge fast forwardable? Yes or no? If we want to merge feat print into master, if we want to merge that feature branch into master, is the merge fast forwardable? If it is, then why? If it isn't, then why not? Anyone? This probably looks very similar to a graph we've seen already in one of the problem sets. So this is hopefully something that you've seen before. This isn't a question that should be new to you. I hope. So fast forwardable. Feat print into master. Yes or no? Remember that a fast forward is the simplest kind of merge that Git does. A fast forward merge is a merge where the only thing that happens is that a branch moves. If you merge feat print into master, is it a fast forwardable merge? If the question doesn't make sense, then tell me so. If you genuinely don't know, then please tell me that. Chepo is saying yes, it is. Very good. It is, in fact, fast forwardable. Very good. And why is that? Remember, what is it that makes a merge fast forwardable? Because it's straightforward. Right, so what you're saying is basically that there's a straight path through history from the branch that we want to merge to the one we're merging into. Starting at the head of feed print, we can follow the arrows and we can back it the branch that we want to merge into. In other words, there's going from one branch to the other, or going from the head of one branch to the other. It's basically a straight line through history, in which case it's very straightforward to integrate the work. We just follow the path of history, just follow the straight line. So what would happen if we now merged feed print into master? This would happen, right? That's a fast forwardable merge. The only thing that happens is that the master branch moves and the head of master becomes what was the head of feed print. And it is in fact still the head of feed print. It'll be the head of both branches. Now at that point, if we did that, would feed color no, let me change the wording. If we now wanted to merge feed color into master, would that be a fast forwardable merge? So let's say that we actually merged feed print into master, so that master ended up being where it is in this diagram right now, here, at the add print feature. If we did that and then merged the feed colorize branch into master, would that now be a fast forwardable merge? So is there a straight path through history now? From the feed colorize branch, or the head of the feed colorize branch, to the head of master. What do you say? Langanese is saying no, because there are changes between the master branch and the feed color branch. Yes, very good. And yes, Katlegi is also saying no, very good. Because if we're going from the color branch and backwards through history, following the arrows, we'll never find the master branch. Meaning that there's no straight line history going from where the master branch is at to where the color branch is, the feed colorized branch is. So at some point, the histories diverged and went out into a fork like this. So, in other words, what Git knows now is that since there is no straight line history, there is going to be changes that happen in both files that might have to be integrated. So if we actually do a merge, if we merge feed color into master, what Git would do is to create a merge commit. And the situation will be as follows. The merge commit will have as its parent the two previous heads, and then master will move along. So let's try and do this. Let's try and do everything we just talked about. Let's first merge the print branch into master, and then we'll merge the colorize branch into master, and end up with this graph. Let's try that. So first thing we need to do is to check out the master branch. We're merging into master, so check it out. And then we're going to run git merge feet print. And Git is telling you it's updating. It's a fast forward. In actually doing the fast forward, the index.js file changed, of course, because there were changes to the index.js file in the print branch. So if you now look at the graph, what do you know? The master branch is now where the feet print branch is at. As expected. This is what we discussed. That's what happens when you do a fast forward. So, is everyone here? And has everyone merged their feet print branch into their master branch? So what has happened now is that we've taken the work that was on the feet print branch and we've put it on the master branch, right? We took the work that was done on the print branch and we integrated it into the master branch. That's how you can interpret what happened. In terms of the data structure, the label just moved and a new commit was marked and tagged as the one that is now currently the most recent commit on the master branch. We just took some changes. We took a commit wholesale from a different branch and we applied it just fully because Git saw that the merge is fast forwardable. Therefore, we can just take the entire commit and that will now be the tip of the master branch. Okay, all of you ready to move on? At this point, we want to merge the feet/color branch. We're still on the master branch, so we're going to run git merge feet colorize. And now we have a conflict, which is what we expected. A conflict is what happens when Git can't automatically resolve every line of code and know what to keep and what not to keep. And we expect this to happen whenever a merge is not fast forwardable. A conflict isn't bad. It's just Git's way of telling you that you have to open a file and tell Git which lines to keep and which not to keep. So if we read what it says conflict content merge conflict in index.js. That means that inside the file index.js, we need to make some choices about what to keep and what not to keep. Let's open index.js. And you can see that Git has put some markers, some symbols inside the file. Basically at every place inside the file where there's where that has been modified differently by two different commits, it will show you side by side what was in the original file, or what was in the one on the branch that you're merging into, and the one commit on the branch that you're merging. So right here, it's showing us that these lines existed inside of the head commit. That is the commit on the branch you're merging into. The branch you're merging had this. And Git is basically asking us, either you have to choose one or the other, or you have to find some way of integrating this stuff. So let's see here. This happened on the feed colorize branch, and we need to keep all of that. And then this is basically the other feature, and we need to keep all of that. But of course we want the print text feature now to use the colorize feature. So let's see, let's move this down because this needs to be at the bottom of the file. Let's remove the symbols that Git put in the file for us, and the end result should look like this. But we're not completely done, because in integrating this work, we want the print text feature to use the colorize feature. So we're going to add colorize inside the text function so that the print text function now also colorizes the text. So the end result of integrating that work should look like what we have up on the screen now. So we had to move some code around. We decided to keep all of the code. There was no code that had to be deleted. But we moved it around a bit because the colorize function has to be up top, since the print text function uses the colorize function. And you can't use a function that hasn't yet been defined. So, you happy about this? You should have now manually resolved the merge conflict. Remember to save. Remember to save and tell me when you're ready. Probably take some time to edit the file. That's fine. Just give me a heads up when you're ready. You're ready. Awesome. Okay. Save. Now let's run it and make sure it runs the way we want it to. And it prints hello Umuzi in zebra colors in whatever that is. And it chooses a random style every time we run it. Ah, neat. Okay, so what we've done now is to actually integrate the work, and we've tested that it seems to be correct. And we still haven't finished the merge because we need to tell Git now that we've resolved the conflicts. And the way to do that is, let's first run Git Status to see unmerged paths. And unmerged paths will show you the files that haven't been merged because there were conflicts. Now, if you add index.js to the Git index, to the staging area by running git add index.js, that's how you tell Git that we're done with that file. The conflict's been resolved. And if you then run Git Status, it'll tell you changes to be committed. Those are the files that are staged and modified in the merge commit. And once you're ready to complete the merge, run Git Merge Continue, Git Merge -- Continue. That tells Git we're ready to continue the merge now. And now we'll be given the option of creating a commit message. And we'll just leave it the way it is. It'll insert a standard text there saying we merged branch feed colorize, and that is exactly what we did. So just save that. Don't make any modifications. Just save it, and we're done merging. Now we've integrated all the code and all the features. And if we look at the graph, let's see if this makes sense. Initial commit, index.js, we fast forward to the print feature. And the latest feature could not be fast forwarded. So we had to create a merge commit. And this looks like it corresponds exactly to this. So this is one way of merging. And let's see, it's now 20 minutes past 11. Okay. We have now seen one way of using Git. Just merge things in order to integrate work. Merge your feature branches into the master branch as the features get ready. And remember, you can always, whenever you start a new feature, you check out the latest commit on the master branch and you continue from there. And whenever your feature is ready, you just merge it back into master. And this is a continuous process that happens for each new feature that you implement in your application. You can always stop working on a given feature, check out a different feature branch, and work on that. It makes it very efficient. If there's something that blocks you from finishing some feature, you can basically just say, yeah, I'm going to put this work aside and I'm going to work on something else now. And this way of working also makes it possible for different parts of the team to work on different parts of the application in parallel. You just check out the latest commit on the master branch and you work from there. And when you're done, you merge it back into the master branch. However, this isn't the only way of merging your work back into the master branch. And I want to show you yet another way of doing things. So for those of you who have the time to sit in for another 10 or 15 minutes, that would be great. To the rest of you, thank you very much for following the course. I'm really glad, really happy with what we've been able to do together. Thank you so much, and I understand it if you have to leave. For the rest of you, we're now going to do one more example of how you can use Git to merge features. The end result is going to be very similar, but the graph is going to be different. So what we're going to do now is we're just going to disregard what we did, this commit. We're just going to move the master branch back here. That basically undoes all the work that we've done so far. And in order to move the master branch back to this commit, we're going to use Git Reset. So what I need you to do is to bring up the terminal, run git log, and find the commit hash of the commit, which is called add index.js. That is, you need to find the hash of this commit. Okay? Open git log, find the hash of this commit. Basically the second commit in your repository. The one that's called add index.js. Here on my side, it's called A7, A1, etc. I just need the first few characters. Now make sure that we're on the master branch. If I run git branch, we are on the master branch. That's indicated by an asterisk. We're going to reset this branch. We're going to do what's called a hard reset. That means that not only are we going to reset the branch, move the branch to another head, but we're also going to check out that commit that we're resetting the branch to into our working directory. Hard here indicates that we're also at the same time checking out the content of the commit into our working directory. So, oh, oops. I need to make sure I have the right commit hash. Git reset hard and then the hash of that commit. And now we're basically back to square one, where no merging had happened at all. So we've undone some changes. The master branch is back to where it was 20 minutes ago. The diagram now looks like this. Of course, in theory, there is still a commit up here, which was the merge commit that we created, but there's no branch pointing to it, so we can disregard it. It's there. In theory, we could bring it back and put it on a different branch, but we're just going to disregard it. It's not important to us. This is what our repository looks like. Okay? You're all happy with that? I'm going to try and run through the next example in 5 minutes, so we're going to speed up a little bit. Again, remember that the feat print branch is fast forwardable now. That means merging print into master. That is a fast forwardable merge. Now, what we're going to do now is to actually force Git to not, we're going to force Git to not just fast forward this merge. We're going to force Git to create a merge commit. So what we're going to do is we're going to tell Git, you know, yeah, we can see that this is fast forwardable, but we still want a merge commit here. Let me see if I can make it all visible to you there. I'd make the graph look like so. Okay? We're going to force Git to create a merge commit even though in principle it doesn't have to. And the way you do that, so we're now on the master branch and it should be reset to index.js. before we move on, can you just confirm that you've been able to successfully reset your master branch? Yes or no? Is anyone still with me? It could be that all of you had to leave and I wouldn't know. So it'd be nice if there's anyone there. Oh, there's at least some people here. That's very good. Has everyone been able to reset their master branch? Yes. Okay, very good. We're now going to merge the print feature again, but we're going to use the no fast forward flag. That means Git will merge the branch, but even if it is fast forwardable, it's going to create a merge commit. So we're going to run git merge no ff, no fast forward, feat print. And it'll then bring up an edit window for the commit message, which you can just leave as is. Merge branch feat print. Save it. And it's now merged. It's now merged the feature branch, but it's created a merge commit. So if we now look at the graph, look at this. Here's where we were at. Here's where the master branch was. Here is where the print commit. Here's where the print branch is at this commit. And now we have this new merge commit up here. Oops. This merge commit, which is the child of the old commit on the master branch as well as the print branch. So you get this spout in the graph. Basically, what you can do is to look at the graph and say, right, so the master branch went from here to here, and on this spout here, that's where all the feature work happened. And then it got merged into the master branch. So basically, it's very easy to see from the graph itself which commits are commits that were fully integrated and were on the master branch, and which contain partial work, i.e. which commits were part of the workflow on a feature branch. So the end result is the same. If we'll look at this commit now, it's going to be identical to, the files are going to be identical to what we did when we just merged the branch using the fast forward strategy. Index.js is going to look exactly as it did last merge we did of the print feature branch. But the graph is different. So we integrated the work, but the history looks a bit different. And as a matter of aesthetics and as a matter of what you like the graph to look like, that could be something that you would want to do. Again, this is all about crafting the commit graph to look like something that you can go back and understand later. You really don't want your Git commit graph to look like spaghetti, just strands upon strands, where it's really hard to follow what happened throughout the history. At least that's my opinion. And often it's better to think about finding strategies of using Git so that the graph becomes easy to understand, so that later on, if you need to go back through your code and see what has happened to it, you can see what work builds on what and where integrations happened. But we're still not done. We've integrated the feature print branch now by forcing a non-fast forward merge. So right now, our graph looks like this. Now I'm going to do something that we briefly talked about in a previous lecture, namely we're going to use rebasing as a tool. And rebasing, if you remember, enables us to move commits around the commit graph. Basically, we're going to move this entire feature colorize branch so that its parent becomes the new head of master. This is what we're going to do. And in fact, let me just move things around so the graph looks a bit more symmetric and readable. There. And there. This is what we're going to do now. We're going to use rebasing in order to move work around, and we're going to move the color branch so that it branches out from, or spouts out from, the new head of master. In essence, what we're doing is we're keeping track of the changes that happened to the master branch, and we're integrating them into our feature branch by moving the entire feature branch along. So what will happen is that when we move the entire branch, there's going to be a conflict that we have to resolve so that Git knows exactly how to get from here to this new commit here, and then all the other changes that we've made are going to get replayed on top. If this is a bit difficult to follow, let's do it. It's maybe easier to understand if we do it in real life. So bring up the terminal. We're going to rebase the color branch, the colorize branch. When you rebase something, you have to check that out. So run git checkout feat colorize. And we're now on branch feat colorize. We're now going to move the entire branch by rebasing it on master. And the way you do that is by running git rebase master. And now it tells us that we have a conflict, and that conflict exists inside index.js. And this should look very this should be very similar to what we've already done. See here, it tells us that we have a colorize method here that could add it at some point that we want to keep. And we have this print text function that we want to keep. Oops. And we want the print text function to use our colorize feature. So it's the exact same change that has to happen, because what we're doing is we're integrating the work, but in a different way. This time we're doing it by rebasing. So once you made those changes again, save them. And once you've saved them, do git add index.js and then git rebase continue. And then once you're done, we can check the graph. And you'll see, let's start at the bottom. Here's the initial commit, index.js. And here's the first feature branch that got merged. And it's pretty, the graphical language here is pretty evocative, right? We spat it out here, we did some changes and we merged them back in. And up here, let's see, this is where the master branch is at. But going forward, there's 2 more commits. These are now the commits that got moved. This is the new feet colorized branch. It now exists at a different place in the graph, right? Going back to our diagram, it used to be down here. It used to be that these commits were down here. And the color branch as well. What we did was to create mirror copies of these with different parents, with a different parent, and these go away. In essence, we moved the branch. There, are you happy about this? Did that process make sense to you? So now in order to integrate the feet color branch into the master branch, we're again going to merge the color branch into the master branch, meaning that we have to check out the master branch, and then we're going to Git Merge, and I need to bring up the terminal. No fast forward feet colorize. Okay, when you do that, the feet colorize branch is then merged, but not through a fast forward strategy. And what happens to the graph is that we get a new merge commit here. Let's see if we can make these arrows a bit more identical. Okay. There. There, and so there. This is what happened. So the graph. Can we wrap this up? Yes, definitely. This is all I wanted to show you. If we bring the terminal back now, bring up the graph, you'll see what it looks like. It looks like what we just did. And the work has been integrated if you run index.js. You can see that all the work has been integrated. You've all integrated the work. You have a working application. The graph looks a bit different. And that's all I wanted to show you. So, instead of waiting for everyone to finish up, those of you who aren't done can go back through the video and try and complete it on their own. I'm very sorry that we went on for this long. I didn't intend for us to. At the same time, I didn't want to leave all these topics hanging since this has been our last class together. Now, all I want to say is thank you very much for all your patience and for following this course. It's been great to have you following this course, this lecture series. This has been a very interesting experiment for me. I've never done anything like this before. I hope that you found the class interesting. Some of it, of course, has been a bit abstract and a bit out there, so to speak. But I hope this will help you going forwards in understanding Git and in using Git as a practical tool. Thank you very much. Thank you so much. You've been great. I've loved every minute of this. Good luck to you going forwards. You're going to be great developers. Keep on trucking. Keep on doing. Keep on working on expanding your skill set. And good luck. Now, that's it for me, I guess. So I won't keep you busy anymore. You have your activity at 12. Thank you so much. And goodbye. Hope to see you again.